My name is Brian Grant. I'm up here in Portland. I'm actually originally from the Bay, so I always like reminiscing by coming to these meetings as well, in addition to you guys being a good crowd. And I guess I'm going to go ahead and start sharing my PowerPoint so we can start talking about some DAX. Welcome to my presentation on an introduction to whiteboarding in DAX with DAX Sketches. So this is going to be all about kind of working through some very basic ideas in DAX, but doing it visually, which is sort of the thing that I'm known for. I'm going to adjust my camera again because I have a background in video and that kind of stuff bothers me. Okay, cool. Okay, so let's start out by talking about the very basics of DAX. So at its deepest heart, DAX is a language of tables. Everything in DAX is about tables, and everything in DAX is done with tables. So because of that, one of the ways that you get good at DAX is being able to see the tables in the code. Once you can do that, actually understanding how the language works becomes much, much easier, right? So one of the takeaways from that, or one of the implications of that, maybe is a better way to say it, is if you attempt to learn DAX by looking at the code, it's sort of like learning chess by looking at chess notation, right? So over here on the left, we've got a game of chess where we've got all the actual moves that happen on that game. And if you're a chess master, you can look at this code and immediately know everything that it means, because you can look at that and in your head, you will recreate the board and all the pieces moving. You can just see it in your head. It's all very, very easy and intuitive, right? But if you're me, not a chess master, barely a chess player, you look at this and you say, I have no idea what that means. I kind of know what some of these pieces are. I think that's a knight, and that's about all I know it, right? So similarly, if you just look at DAX code, right, and you see all this stuff in here, you've got all these functions, and the names are reasonably intuitive, but because they're working with tables, it's kind of hard to understand what it's actually saying, right? Because this code over here is actually orchestrating the execution of tables, but it's hard to see that by looking at a lot of text, right? Pictures as 1,000 words, right? So what we want to do is we want to get good at seeing the DAX in the code. So if we're thinking about chess, there's this concept of board vision. And board vision in chess is the ability to see how the pieces move and interact on a chessboard. The skill is critical to part of the player's chess foundation, right? So said otherwise, if you want to get good at chess, you need to be really, really good at being able to glance at the board and immediately pick up all the pieces and understand how they interact with each other, right? So we're going to have a similar concept, right? In DAX, we don't have board vision, we have table vision, right? What is table vision? Table vision is the ability to look at a block of DAX code and quickly see, in quotation marks, simplified versions of all the tables involved and how all those tables are interacting to produce a final answer, okay? And by see, we mean, imagining in your head, right? You don't literally hallucinate them. So the idea is, if you've got a big block of DAX code like this is really scary for new users, right? We've got all these variables and these functions, you don't know what they do. And I look at this and I say it's easy. And it's kind of almost cruel. They're like, how can you say that's easy? This is very, very difficult to understand. Well, when I look at this code right here, I glance at it very, very quickly. I don't see the code. What I see is the tables involved in the code, right? So if we've got a measure called returning customers, I just look at these functions that are being called and I say, yeah, we're going to get a table that's got all the days last year. We're going to convert it to a filter. We're going to use that filter to get a list of all the customers from last year. We'll get a table of all the customers from this year. We'll figure out which rows are in both tables. That'll be this table right here with the customers in both years. I'll count how many rows are in this table, and then I'll have my answer. So if you can imagine this as a collection of interacting tables, it's not that hard to work with. The trick is you need to get good at actually being able to look at all the names of all these functions and understand the tables they produce. See these fuzzy gray boxes just alongside the code, or sometimes like in the back of your head, maybe, right? Okay, so I will say part of the ability or part of the skill in table vision is being able to look at code and translate it into these fuzzy rectangles. In practice, maybe the more important part of it is being able to do the opposite, right? So if we start with a completely blank measure, and I know I'm trying to write a measure called returning customers, in my head, before I write a single line of code, I go imagine all the tables that I need, Okay, well, I'm going to need a table for all the dates last year. I'll use that to generate a table of all the customers for last year. I'll get the customers this year. I'll figure out which rows are in both tables, and I'll count them, and that's it. So in my head, before I write a single line of code, I imagined all these tables that I need, and then all I got to do is write the code that makes those tables, right? So that is at the heart of table vision. That is why somebody who's been doing DAX for a long time, it's so frustrating to sit and work with them, because they can look at this code and they go, yeah, it's easy, because they see those tables right over there. If you can't see those tables, it's basically almost impossible to figure this out, or at least it's very, very slow, okay? So I'll pause. Any questions about what I've talked about so far? You can throw them in chat, or you can just yell at me. Feeling pretty good? Okay. So this is great. Brian, I love this, except there's one small problem. I don't know how to do it yet. And it's great that you show me that you can do it, but like that doesn't help me. Or you're not going to follow me around at work and show me how to do all this stuff. How do I actually build this skill, right? Well, the idea is I created this new thing. Maybe it's just a gimmick, but I hope not. I hope it's just a useful tool. And it's called DAX Sketches. So the idea behind DAX Sketches is it's a technique for drawing out DAX evaluations, whiteboarding them out, essentially. And it attempts to whiteboard out essential concepts like temp tables, iteration, row context, and filter context. Draw it out so you can just see it and then build that ability to get that table vision in your head, right? And what it looks like is kind of like this, right? Oh, it requires one black and one blue marker, right? And a red one if you got it. So the idea is you could take a measure like this, sales old dishes that has all this stuff, and you could get a big whiteboard and you could sketch it out and draw it and say, this is what's happening, right? So when I've got this code over here that's doing all this stuff, I can actually render out all the steps in that evaluation on a whiteboard so I could see the changing of the filter context, I could see the creation of row context, and I could see how all the different tables interact. The idea is, in addition to making a lot of the steps more explicit, if you could see stuff drawn out this way, it helps you see those fuzzy rectangles when you're actually writing the code yourself, okay? Okay, questions about this before I keep going? Good, okay. So, before I get into DAX Sketches, I need to take a moment and talk about what I call friendly DAX, which I also call the Pocket Translator. What do I mean by that? Well, I'm going to introduce two actors in this play that I'm putting on right here, right? We have a human, and we have the Analysis Services Database, or the DAX engine. You know, if you want, I'll just call it DAX engine from this point forward, right? So humans, or this human, anyways, and humans in general, they'll say things like, I'm good at thinking about real-world concepts and ideas, and I can also roller skate, right? The Analysis Services Database engine is not good at thinking about real-world ideas and concepts, and is also not good at roller skating. The Analysis Services Database engine is good at using joins to create table values, and then performing table scans to do aggregations. Now, if you're saying to yourself, I don't know what any of that means, that's fine, because you're probably a human, not an Analysis Services Database, right? So why do I bring this up? A person will say things like, hey, I'm going to need to figure out how many customers we sold stuff to. I need to figure out how much money did we make. And when they do that, what they will do is they will write some DAX, but it's a specific form of DAX, right? They'll write something like distinct count of the customer ID column in the sales table, or sum of the sale amount column in the sales table. This is what I call friendly DAX. And the thing about friendly DAX is it's nice and it's useful and it's friendly. However, it is basically a shortcut way of writing a more low-level version of DAX, if you will, right? So whenever you write functions like distinct count or sum, and there's several others, right? You think to yourself, oh, I'm writing this DAX, and you are, but internally this is being translated into something more that the Analysis Services Database can understand more directly, right? So all this friendly DAX is going to get translated what we call mechanical DAX before executing, right? So when I write distinct count, this immediately gets translated into values of the customer ID on the sales table and then account rows wrapped around that. What feels like one function to the human is actually two functions sort of hidden into one or prepackaged conveniently into one. If I write sum of sales amount, right, this right here, this feels like a single request. this has to get translated into this longer form where it says SUMX sales sale amount. This is something that can be understood by the analysis services database, which has no idea what any of this means, right? Now, this is good because it means a new person at DAX is able to use these fairly easy to understand functions and get the results that they want. It's challenging though, because if you try and understand DAX by using this friendly DAX, you're not really speaking the native language. You sort of have this layer in the middle, right? So like a pocket translator, the friendly DAX can be very handy for navigating a new place or a new language or something like that. But if you want to get really good at something, you have to learn to speak the native language, which is mechanical DAX. So it's the reason I bring this up, right? So for occasional use, friendly DAX is great. You need to learn the native language if you want to do it. When we're sketching stuff out, I can actually sketch out friendly DAX. But the way that it works is I will actually write out the mechanical DAX version of it. So if you try and sketch out friendly DAX, it's just not as useful and interesting. By contrast, sketching out mechanical DAX works very, very well, and you learn to start thinking the way that the database engine works, which is kind of what you want to do. Okay. Oh, let's see. Oh, okay. Hybrid mix. Great. Okay. So that said, right, all the stipulations out of the way, let's actually start sketching something out, see what sort of this stuff looks like. And we're going to start with the initial filter frame of a measure, right? So if I've got some measure in a Power BI report, right, there's a measure there, and I've got two slicers next to it. I've selected lunch and I've selected to go. This measure, which we've written beforehand, right, it's going to get evaluated with these filters in place. So whatever this measure is, whatever it's called, it will run with a filter for lunch and to go in place, right? That seems kind of obvious because that's what the end user expects, but it's worth mentioning, right? So how do we actually draw this out? How do we draw this out? So we've got that measure in there. That measure is going to evaluate what we're going to describe as the filter frame. The filter frame is just a way of visually indicating the bounds of the filter context evaluation, right? And so by that, I mean we draw a little box, right? So we've got this box here. This box is the filter frame that has the initial filter context of this measure. This measure, because it's evaluating with these two slicers set to lunch and to go, will run with one filter for lunch and one filter for to go. If I set this to dinner and dine in, this would say dinner and this would say dine in. If I turn both of these off, the filter context would be empty, okay? So the frame is a way to indicate what are the initial filters that we start with and what do we do with them, right? Okay, so everything that we write inside the measures definition is what happens here, right, inside the filter frame. The filter context will affect the behavior of the evaluation, but whatever you write, be it a total sales measure or a customer count measure or whatever it is, will happen inside this frame every time it runs to generate a number, okay? Okay, so that's interesting by itself, but what I want to know is what else can I do with it, right? Why do I bother sketching this out? I don't think I need to draw this out to understand it. Well, let's talk about probably the most powerful thing you can do in DAX. Jump right in, right? And of course, as you might have guessed, it's the calculate function. What does the calculate function do? Let's sketch it out, right? So what the calculate function lets you do is create a frame within a frame. So if I've got this measure here, right, and it's running in this initial filter context, what I could do is inside my measure definition, I could call a very special function, the calculate function, to create a frame within a frame, right? So if inside my measure here, I use this calculate function, what I'm saying is create an inner frame that has a modified set of filters or a modified filter context, okay? So when I call calculate, calculate creates this inner frame, right, just like this, and it has a new filter context or a new set of filters, right? And if you'll notice in this new filter context, we still have the filter for lunch, but we've gotten rid of this filter for to go. Now, why do we get rid of this filter for to go? Well, if you look at argument 2 of calculate is remove filter on sale type, right? So what we said here with calculate is create a new frame that has a new filter context on it and get rid of any filter on the sale type column. So it looked at the two filters that were out here and say, well, this one's on the sale shift column. That one's fine. I'll leave that one alone. This one is on sale type. Oh, they want me to get rid of that one. And so calculate does that. And now that I've got this new filter context with a filter for just lunch, but not to go, now calculate will run whatever I type in argument 1. That could be a big, complicated thing. It could be very simple. But argument 1 of calculate, which I will call sometimes the new filter formula, right, or the new filter sub-expression, is the set of instructions that runs in this new frame where we've got different filters than we had by default. Okay. I'll pause. Any questions about that so far? Feeling pretty good? Okay, dig it. So, what else can we do? We've got this ability to change what the filters are. Is there other stuff? Yeah, there is, right? The most important of which is taking a snapshot. Taking a snapshot. What do we mean by that? Well, let's revisit back here. We've got our measure like before, and we've got the same initial filter context for lunch and to go. We want to actually do some stuff in here. So up here in our measure, we're going to add some code, right? Oh, by the way, here's the actual data model that we're working with. If you've seen my videos before, you're probably overly familiar with this and tired of looking at it. This is our sale data model. It's got this one table that's got 7 sales transactions, 4 for lunch, 3 for dinner, and some of them are to go and some of them are dine in, and people buy different stuff, right? So if we've got this measure, we're going to add some code. We're going to add some code that does the following, right? We're going to use the values function, and we're going to point it at the sale dish column. Okay, sale dish is the dish column in the sale model table. So this is the data that we loaded in from Excel or from SQL or wherever we loaded it into our data model. And in our measure, we say, go get all the distinct values of that column. Okay, this is what we call a snapshot, right? A snapshot is an operation that produces a temp table. A temp table is exactly what it sounds like. It is a table that only exists for the evaluation of a measure or a query, right? Just long enough to produce a number. So here in this measure, by calling value sale dish, this snapshot is going to produce a temp table. And in our sketch, we draw it with a little camera right here. We write out what the snapshot is. And then we write, importantly, what it produces, right? So it produces a temp table, right? Now, I could render out the temp table, but when we're doing the DAX sketch, what we do is we draw a little rectangle, and then we write a couple bits of information. We say that in this temp table, this contains the visible column values of the dish column in the sale table. And by the way, it is a 2-row by 1 column temp table, right? So the snapshot, or any snapshot, is a function that takes a picture of some asset in the data model. That asset could be a single column, or it could be the entire table. And when it takes this picture of it, what it produces is a temp table, a table that you can use in your evaluation, okay? Now, if I were to draw it out, because this data model is small enough, I could say, hey, that list of all the visible values in the dish column looks like this. It's just got pasta and burger. Notice that the rendering of this temp table is a little different than the model table. I draw them differently to convey the idea that this table is only temporary. Notice also, this part is important, right? If we look at the dish column in our data model, we see that we've got pasta, burger, burger. Oh, people are being real unhealthy. And then down here we have salad, right? And yet in our temp table, we only have pasta and burger. There's no salad. Why are we getting salad in this temp table? Because we've got a filter for lunch and to go. So when we get all the values of the dish column, this snapshot pays attention to the filters in the filter context and ignores all the dinner rows. It also ignores the dine-in rows. It just looks at lunch and to go. And if you're just looking at lunch to go, you're looking at that one, and that one. And so people have only ordered pasta and burger. Therefore, we get pasta and burger in that temp table. Okay. Questions about that so far? Okay. So what other, oh, I'm sorry. We draw the temp tables with 3 important pieces of information. Let's actually go look at those pieces of information, right? The description, which is here, I've got it underlined, the visible column values. Then we render what column or columns it's based off of. This one is based off of the sale dish column. Fancy folks will refer to this as lineage. We could just say, what column is it based off of, right? And then its dimensions. How many rows is it by how many columns? 2 rows by 1 column. We describe that temp table right there, okay? Okay. So again, we've got our description, which column it's based off of, and its dimensions. And if we were to have different temp tables, like a temp table that looked like this, we might call this the visible rows, right? Because it's got all the visible rows of a given table. And it's not just one column, it's not sale dish, it's all the columns of sale. So I'll put a little asterisk in there, right? Just like we're in DOS mode, right? And this is 3 rows by 5 columns because it's 1, 2, 3 rows by 1, 2, 3, 4, 5 columns, right? If we had a different temp table that looked like this, we would say this is just the lunch. Lunch is all that's in there. It's based off of the shift column in the sale table, right? Sale shift. And it's 1 row by, oh, that should just say 1 row by 1 column. I thought I got all the bugs out of this. Sorry about that. Okay, so let's talk about some of the other snapshots that you can take, because I think it'll make more sense what a snapshot is if you can see a couple different examples. Okay, there's 4 common snapshots that we're going to care about. We've already looked at one of them, so we're 25% of the way done. But we'll look at it again, just because repetition is helpful with this stuff, right? Again, we've got our data model here, right? It looks like that, 7 transactions. So this, if we type in values and then give it a column, I call this the values column snapshot because I'm not very creative, right? Use the values function and you point it at a column in the data model. What do you get? You get a single column that is filtered, right? That represents all the visible values in whatever column you told it to go get, right? So it looks like that, okay? What other snapshots are there? Well, the next snapshot is probably the most important snapshot in all of DAX, right? And it's also, in some ways, the most confusing. It's a little bit tricky. So here, I just type in the name of the table. This is the sale table. So I just typed in sale. I didn't wrap it in any specific function or anything like that. And if you refer to a table and then don't specify a more specific snapshotting function, what you get is what I call the auto snapshot, right? Automatic because it doesn't require any specialized function. You just type in the name of the table, right? So if I type in the name of the sale table, what I get is not all 7 rows, but just the visible rows, right? It's multiple columns, but it's filtered. So if I type in sale, but I've got this filter for lunch and this filter for to go, I'm just going to get the 1, 2, 3 lunch to go rows, right? And sure enough, it looks like that, okay? So I can do values and point at a column and get a temp table that looks like that. I can just type in the name of a table, right? And get a temp table that looks like that. What else can I do? Well, let's say that I hate these filters. I want to ignore them. There's a couple snapshots that ignore the filters, right? And they're pretty easy to remember. You just use the all function, right? So this is called the all table snapshot. If I refer to a table but then wrap it in the all function, it knows that I don't want all the visible rows. I want all the rows, visible or not, right? So it's multiple columns, but it's unfiltered this time. So instead of just getting the 1, 2, 3 rows that are the lunch to go rows, we get all 7 rows, ignoring the filter for lunch and ignoring the filter for to go, right? Okay, so the last snapshot that we're going to care about is actually pretty similar. It's basically the same function, the all function, but this time, instead of pointing it at the entire sale table in the data model, we're going to point it at the dish column in the sale table, that column right there. And what are you going to get? Well, it's going to be very much like this up here, except instead of getting a filtered version, you get an unfiltered version, right? This is the all column snapshot. It gets the values of a single column, but this time it ignores the filters. That's what the all function does, right? There we go. It produces that temp table right there. So those are the 4 common temp tables that you will use in DAX. And this is the ones that I use 95% of the time, and I use these in pretty much every measure I write. It's very, very difficult, basically impossible to write a practical DAX measure that doesn't use some snapshot, whether you write it out explicitly or whether it's hidden in some friendly DAX, okay? So, okay, so we've got these temp tables. What do we do with them? Let's start with something simple because we've got enough hard stuff, right? The simplest thing we could do with them is we could take a temp table, right? I could get the auto snapshot here, get the 3 lunch and to go rows, and I pass it into the count rows function. What does the count rows function do? It's not terribly exciting, but it's actually pretty predictable. It counts the number of rows in that temp table. So you tell me, how many rows are in this temp table? Let's see, well, 1, 2, 3. See, it's 3 rows by 5 columns. Count rows produces the number 3, right? And that would be the result of that measure right there, okay? Hey, Brian, that's not very exciting. Is there anything else we could do with it? Yeah, this next one's a little bit trickier, but this is the other one that you'll use all the time, right? Okay, so let's say that I've got a snapshot, same snapshot as before, the auto snapshot. I've got all the visible rows of the sale table, the lunch and to go rows, right? So I'm going to take that snapshot and I'm going to pass it into the SUMX function. SUMX is an iterator, right? What does an iterator do? Well, as you can imagine, as the name implies, it iterates over a temp table. That sounds kind of confusing. What it means is it's going to take that temp table and go row by row through that temp table and run what I call a per row formula. Okay, so let's look at that. Let's see what that does. Okay, so we take this temp table right here, we pass it into SUMX. SUMX is going to build 1, 2, 3 row contexts, right? Because we've got 1, 2, 3 rows in our temp table here, right? So I'm going to just draw them out like this. There's one row context, there's a second one, and there's the third one. Okay. So when we're talking about iterators, you can imagine them sort of like a deck of cards, and on each card on the left half is the row context, and the row context is just all of the values of the current row. So if we look down here, right, this one is lunch to go, pasta 2 and 7. That looks like it's that top row right there, right? So this row in the temp table has been turned into a row context that represents all the values of that row. Okay. This here, this second card, is the row context for the second row. It's lunch to go, and this time it's burger, $1 and $9. Lunch to go, burger, $1 and $9, right? And if we look at this last card right here, this is going to be the row context for the third row, where we've got lunch to go burger, $3 and $9, right? So if we see the row context for each card represents all the values of the current row, sort of like a hash table, if you're familiar with that concept, a set of named values, numbers and text strings that you can call and work with. Speaking of which, what do we do with this, right? So SUMX, like any iterator, will take a temp table and create a set of row context, one row context per row, right? And what does it do with it? It runs a per row formula, right? If you prefer a row contextualized sub-expression, if you like fancy names, I call this the per row formula. Argument 2 of SUMX, or in an iterator, is the per row formula. It is the formula that will run once per row. So because here in SUMX we've typed in sales quantity times sales price, we will run that exact same per row formula inside each and every row context. And I think you can see where I'm going here, right? It's the same exact formula, but in the different row context, it will generate different numbers because the reference to quantity in one row is different than the reference to quantity in a different row. Okay, so let's just sort of look. Let's look at this top row right here. It's kind of hard to say that it's the top one, but it's the top of the deck, if you will, right? So this is going to run these per row formula, sale quantity times sale price. Well, in this row context, sale quantity equals 2 and sale price equals 7. So sale quantity times sale price is 2 times 7. What is 2 times 7? Last I checked, 14, right? My math is still pretty good. Okay, well, let's look at the second row context, the one for that middle row right there, right? It's going to run the exact same per row formula, argument 2 of the iterator. And this time, the reference to sale quantity and sale price points to the numbers 1 and the numbers 9, right? So in this row, we get 1 times 9. And what is 1 times 9? Last I checked, $9. Okay, let's go to the last row. I think you can see where this is going. We run the exact same per row formula. We run the same per row formula every single time, right? Never ever changes. But this time, quantity refers to the number 3 and price refers to $9. So what is 3 times $9? $27, right? Notice we run the same per row formula, or per row contextualized sub-expression, if you like long names, for every single row, and in each row we generate a number. What do we do with these numbers? Well, this is the SUMX iterator. So SUMX, as you can guess, sums them up. 27 plus 9 plus 14. I got this wrong the very first time I did this presentation. It was very embarrassing. This time, hopefully, 27 plus 9 plus 14 is $50, right? And that's how iterators works. That's how SUMX works. It's how, average X does the exact same thing, except at the very end, instead of summing up the numbers, it averages them. What does min X do? It does the exact same thing, but at the end, it takes the minimum value. Average X takes the average value. Concatenate X will take all those values and squeeze them into a single text string, right? All of these iterators basically work the exact same way. You give them the temp table, it splits it into a set of row contexts, right? And each row context represents each row in the table you gave it and all the named values of that row. And then you provided a formula, and the formula is what you want to run for each one of those rows. It does it, generates a bunch of numbers, and then does whatever you told it to do. Sum it up if it's SUMX, average X if it's average X, etc., etc. Okay? I'll pause. Questions about this? I often forget to breathe and drink water if I don't take breaks. Okay. No? All right. I answered everything. What else is there to say? Okay. So we've got, that's one of the things you do. This is the biggest one. So the combination of snapshots and iterators, we're already basically 2/3 of the way through the core components of the DAX language. Mastering this is very, very difficult, but the basic concepts are not that hard. Why can't we just use sum versus SUMX? So you can use the sum function. You can use the sum function, right? And what does the sum function do? It does this exact thing here, right? There is no sum function in DAX except that it gets translated into SUMX. Some people refer to it as syntactic, or I can't say this. I just never get this right. Syntactic sugar, right? When you write sum, before it gets evaluated, it is immediately translated to SUMX. So let me be really clear about that, because that's sort of a big one. I'm going to exit here and go to my very favorite development environment, which is, of course, Notepad. Brian, you mean Notepad++? No, I just mean boring old Notepad. Right, nice and easy. Okay, so I'm going to do some. Let's do some. Let's do sale, and let's just pretend that there's an amount column, right? Okay. If I write this in DAX, I can write it and I'll get a number, and the number is the number that I think it is, right? I'll get what I expect. The behavior, though, internally is this internally gets translated into the following, right? SUMX, the auto snapshot, and a per row formula, right? So this gets immediately translated to this. You get the same results. You can do either one, it's fine. But if you want to understand what the engine is doing, it is doing this version right here. When you write sum, you both have a snapshot right there, the auto snapshot, and you have a per row formula. This part here, the snapshot, that's going to be kind of important, because as we're changing the filters, the thing that affects is the snapshots. So as you're trying to debug your formulas, if they're not working, if you can't see the snapshots because they're hidden inside this syntactic sugar version of DAX, it's a little hard to see what's going wrong. You can do it if you want to. I still use the sum function. I use the min function. I use the max function. But when I really get stuck, I will translate them to this longer version, because it'll help me say, oh, yeah, if I've got calculate way up here and it's affecting this snapshot right here, that's what's going wrong, right? That's why I think it's worthwhile learning this sort of long form version of it. Asked a very simple question. You got like a 5-minute answer, right? Okay. First off, is that a good answer? And are there any other questions out there?
So Olga posted the question, why can't we just use sum, not SUMX?
Oh, yeah. So that's sort of what I was getting at, right? You can use either, right? SUMX makes explicit what you're asking the DAX engine to do. Sum is easier for a human being to understand. I would say if you are a casual DAX user, use whichever one you like. And frankly, if you're not doing DAX more than like a couple hours a week, use a simple version. It's fine. If your job is to get really, really good at DAX and be the person in the office that masters it, yes, sum is friendly DAX. That's exactly right, right? If your job is to master it, you need to understand how this is being internally translated to this, and understand how this is being interpreted by the DAX engine. Are there any benefits to writing out measures for the DAX engine? No, it doesn't matter. Is there like a speed benefit? No. I feel like on some of the very earliest versions of DAX, there was a slight speed benefit, because if you use sum, it guaranteed some properties of when it did the table scan, but not anymore. They're the same. The only real benefit is human readability, right? So if you're writing DAX for your coworkers and you totally understand this, use the simplified version. Use sum, use min, use max, right? Because they don't need to understand it. That's your job. If you've got a team of 5 people and you're trying to train those folks how to work with DAX, or you're just trying to learn it yourself, I would suggest use this whenever you can. That'll help you see what's going on, right? Develop that table vision. Okay, I'm going to keep plowing ahead because I got a lot of content. Okay, so hey, we just did that SUMX. That was fun. Okay, so what's next? Hey, Brian, you did this whole big giant thing. Good God, do you have to do that every single time you write out your DAX sketch right here? Do you have to write all this stuff out? I've got a temp table with 42 million rows. That's a very big whiteboard you're going to need to draw that out. No, so if you're in a classroom setting and you've got a very small, like a play data set, like I got here, DAX Sketches will allow you to write it out all the way. In practice, I would shorten in a variety of ways. The most common way I would shorten it, if I was still trying to be kind of verbose, is I would draw the set of row contexts, the collection of row contexts, as sort of this deck, like a stack of cards. And I always draw 3, even if there's 45 million of them. Sometimes I'll write about how many rows I think there are. Hey, I think there's 45 million rows in this because I think the temp table's going to be about 45 million rows tall or something like that, right? But I still write out the row context. Another shortened version I could do is I could say, I just need to know that there is a row context. So I'll just write r/c and write 3 little dots. And then I'll write PRF or per row formula. And here's where I'll write out what the per row formula is and what it's doing. Or I could say, no, this iteration's so darn easy, I'm actually going to sort it all the way, right? I'm just going to draw the temp table, a little arrow that goes down to indicate that we're doing iteration. We're scanning it. We're going 1 row at a time. And here where it says E/R, that's not the TV show from the 90s. That stands for each row. That means for each row, I'll multiply the quantity times the price. So I can make this very big and verbose if I'm in a teaching environment. If I'm working with coworkers and I just need to try and sketch out what's happening, I can make it a bit more compact as well. Okay, so now what I want to do is I want to show you sort of the 4th concept, and I'm kind of cheating a little bit. There's actually only 3 key concepts, and we've already covered them. This next one will feel like a different concept, but it's the same concept we just went over. Let me show you what I mean by that. We're going to look at SUMX versus filter. Right, SUMX versus filter. You probably could have guessed that if you compare SUMX to average X to min X to max X, I think I've said it like 5 times now, the only thing that changes is what you do with the numbers when you're all done. What you might not believe is the filter function is basically the same as SUMX, right? So here we are, back where we left our heroes, right? We've got this snapshot where we've got all the visible rows of sales. We pass it into the SUMX iterator. It creates these row contexts and runs the per row formula and sums up the results. Fabulous. I can write a different measure that looks like this. This one is using the filter function, not SUMX, but filter. It's going to go over the exact same snapshot, and it's going to have this per row formula. So right now, we're looking at this version right here. Let's redraw this so that we're looking at this version right here. You guys ready? That's it. That's all the change. Let me go back. Okay, here's the old one. Here's the new one. SUMX versus filter. They're almost the same thing. Now, I think just visually looking at it, you get a sense that, yeah, I get, Brian, that they're pretty similar looking. I get that when you went back and forth, the image didn't change very much. Mechanically, why are they similar? Well, they both do the same thing. They're both iterators. You give both of them a temp table, right? So right now we're looking at the filter version. You give filter a temp table, that same temp table we got right here. It splits it up into a set of row contexts, just like SUMX. Whatever argument 2 was, that's a per row formula that runs once per row. The difference is, instead of multiplying the quantity times the price, this time for each row, we're asking if that row's dish equals burger, right? So if we start here on the top row of the kind of oddly shaped deck, in this row, does dish equal burger? Well, dish equals pasta. Pasta does not equal burger, so we get a false. In this row, the reference to dish is burger, because this is a burger row. Burger equals burger. Yep, we get a true. And on this row, the dish is burger, right? So the dish is burger right there. Does burger equal burger? We do, so we get a true. And filter, what does it do with it, right? You can imagine if it's a deck of cards, it takes all the cards where we got a true, it keeps those, and it throws away the false cards, right? That's what the filter function does. It's just an iterator, just like SUMX, like average X, any of them. The biggest difference is that the per row formula, it needs to return Booleans, trues and falses, to determine which cards it wants to keep. And the other big difference, as opposed to returning a number, it returns a temp table, right? And in this case, it's a temp table that has all the burger rows, right? Getting rid of that pasta, right? And it's 2 rows by 5 columns. Okay, so all right, I kind of get that SUMX and filter are different. What would I do with this filter version, right? Well, the idea is, by the way, there's what it looks like, right? So it's 2 rows, right? It's basically this temp table. We just kept that row and we got rid of the pasta, right? That's what it produces. So what do you do with it? What do you do with it? Let's pivot this a little bit. So what I could do is when I use that filter function paired with a snapshot, I will take the resulting temp table and I will give it to the scariest function of all, the calculate function. What does the calculate function do? We already talked about the calculate function. Calculate is for when you want to create a frame within a frame. So out here, we've got a filter context with lunch and to go. And now with calculate, we're going to say, hey, calculate, take this temp table right here and add it to the filter context. Calculate says, sure, I can do that. Easy. Now we create a frame within a frame, right? This inner frame in here that has this new filter for just those burger rows, right? And for what it's worth, the filter context, if you were like maybe guessing this at this point, the filter context is just a set of temp tables. This is a temp table. We saw that a second ago. This is a temp table, and this is a temp table. At the very beginning, I said that in DAX, everything is temp tables, and that's what I meant. Even the filters are temp tables. If you're thinking to yourself, these filters are like a where clause, no, they're not. They're temp tables that do what's called a semi-join that will act as a filter. So it's a table as a filter. So when you want to create filters in DAX, you use the filter function to generate the temp table that's the shape of the filter you want. Then you give it to calculate that actually adds it as a filter, right? Why would you want to do that? Because you can then do something like this, right? So this is sort of the equivalent code right here. Calculate, filter, all this stuff right here. That's all the stuff we did right there. This produced that temp table. We gave it to calculate as a second argument. Boom, it created that filter context for us. And here, argument one of calculate is whatever we want to run inside that new filter context, inside that new frame. So let's say that we wanted to run total sales. Let's say we created a measure called burger sales. How would we do it? Well, we already have a measure called total sales. And all I really want to do is run the instructions for total sales, but do it with this new filter for burger. This is how I do that, right? The calculate function, right, will then add the filter that I defined up here to create this new filter context, and then it will run total sales with that new filter in place, right? And that's how DAX works, right? So it's important to note that if you have a measure like total sales, I defined that a long time ago, some other day, some other place, right? I cannot modify the code of the total sales function. So if I want to run total sales but want it to just be for burgers, I can't go inside of total sales and monkey around with the code in there. I can modify the filter context that it runs in. I can modify what filters are in place when it runs. This allows me to add filters that penetrate inside that measure. Okay, that's why it works like that. Okay, you guys got all the core concepts of DAX. Is it easy? No. Is it simple? Yeah, it's kind of simple, right? Like you're probably not going to walk away and be a DAX master, but you've covered kind of everything. Okay, so let's summarize this real quick. Okay, so we've got our filter frame, which is a way of just basically encapsulating our filter context and all the stuff we do with it. We know that we've got this function calculate, which is sort of a more generic or a more specific version of what I call the framers, and it creates one of these inner frames. And what does it do? It creates a frame within a frame with some modification to the filters. Maybe it gets rid of a filter, maybe it adds a filter. It can do a few other things as well, but those are kind of the two big ones. And then it does something else, right? That's what calculate does. That's all it does. Okay. So what else do we have? Well, if we remember, we've got our snapshots. Those will give us the temp tables, right? It'll tell us to take a picture of stuff in our data model, right? We've got a couple different versions. We could use the auto snapshot to go get all the visible rows of whatever table we're talking about, like sale, something like that. We could use values to get the visible values of a particular column, or we could use the all function to ignore whatever filters are in the filter context. What do we do with those snapshots? Well, there's several things you can do with them, but frankly, almost always what you're going to do with them is give them to an iterator, right? Most of the time when you're new, you'll give them to an iterator like SUMX or AverageX or MinX or MaxX. We call these the aggregation iterators, right? They take that temp table, split it up into a set of row contexts, and run a per row formula or a row contextualized subexpression, if you like fancy terms. I like per row formula. It is a formula that runs once per row of whatever table you gave it, right? It runs that per row formula for each row context, referencing the values of that current row, of each current row to be specific, generating a number for each card, and then aggregating the results. Which aggregation it does just depends on which one you use. If you use SUMX, it sums it. If you use AverageX, it averages it. MinX, mins, MaxX, maxes. MedianX, medians, right? You kind of get the idea. And lastly, what do we got? Well, it's the same thing. It's the iterators, but this time it's the, I call it the filter prep iterators. It's just the one. It's filter, right? This one takes a temp table, runs a per row formula, just like before. The only difference is that per row formula has to return trues and false to determine which cards in the deck you're going to keep and which cards you're going to get rid of to create that new temp table. And you can do several things with it. You can give it back to a different iterator, or usually you'll give it to calculate to add as a new filter in a new inner frame. And that's it. That's all the hard concepts of DAX. Mastering it is difficult, but the basic ideas are not too tricky. Okay. So after all that, who's got questions? Who's got questions? I've got an example I could do too, but I'll pause first and see if we got questions out there. Nailed it.
I don't see any new questions in the chat, but everybody, you're free to unmute yourself as desired.
That's exactly correct. So the majority of calculations are done with Calculate, since it allows big flexibility with the filters. That's exactly correct. Calculate is sort of the, excuse the reference, some folks will love this, other folks will be like, what are you talking about? It's the portal gun of the DAX world. So there's a game called Portal where you could shoot like a hole in the wall and then shoot another hole in the wall, and if you throw a baseball through the one hole, it comes out the other hole. It basically allows you to break the rules of physics. It allows you to create filters that are not the default filter set. So it gives you huge amounts of flexibility. It's hard to think about because you have to keep track of these nested frames within frames within frames. But at its heart, it's very simple. All it's doing is manipulating the filters. And in doing so, it gives you huge amounts of power. That is absolutely correct. Absolutely correct. I like it. That's my favorite question of all. It's my favorite question of all. Any other questions out there? You guys want to see one? Like not on a computer screen, but like on a piece of paper?
Sure.
Okay. So let's do one of these. Last time we did this, or we switched to this camera, it completely destroyed Teams. So if it does, good night, everybody. Thanks for coming out. Hopefully, this will not crash Teams. Let's give it a shot. If it does, I'll try and come on back. Let's see. So I got to go turn the camera off. I'm going to stop sharing. And I'm going to go to camera. And I'm going to set this to, I'm not sure why VMix is on here. That's kind of fun. And I'm going to remove the blur background. That took me 20 minutes to figure out last time. Can you guys see my screen okay? No, because I haven't turned on my camera. Let me try this again. How about now? You guys see that okay?
Yes.
Okay. So, hey, look, this would be even better if I had like a...
It did warn us.
Uh-oh.
Team screwed up. It froze.
Someone's present.
I was about to post this fingers crossed in the chat.
Oh,
I had it ready.
What do you? I can hear you guys again. I thought we got killed. Are we still around?
We are here, and we can see your pen in the middle of your pad, stationary.
So I was going to share my screen, but I realized that's a terrible idea. What I'm going to do instead is just sort of show you the measure, and we're going to see if we can get more than 5 minutes without Teams crashing. That'll be fun, right? So for what it's worth, here's kind of the measure. This is going to be total transactions, all dishes. It's a pretty simple measure. What we're going to do is we're going to use Calculate to manipulate the default filters. We're going to remove any filter on sale dish, and then we're going to run this new filter formula here, where we go take the auto snapshot of the sales table and count how many rows are in it. Easy as that. Said Brian, who had to do it. Okay. So I'm going to start. I'm going to put my data model here on the page just so you can see what it looks like. It's the same rows or the same values as before, right? Same 7 sales transactions. So let's create the initial filter context and its initial frame. Okay, so if you're sketching stuff out, do not draw straight lines. This is designed to be a sketch. It's designed to be done quickly. Okay, so the name of this measure is total transactions. Should have used a shorter word. Total transactions, all dishes. So hopefully you should get the total transactions for all dishes, right? And we're going to run it with 2 initial filters. So we're going to imagine a filter context where a user has used a slicer to set 2 filters. The first filter is for lunch.
right? And this is going to be, we've got that filter right there. It's based on the sale shift column. And it is one row by one column, okay? And the second filter, initial filter that a user selected via a slicer will say is on the, is for pasta, right? Because people like pasta, okay? This is not on the shift column, but the sale dish column. It too is one row by one column, okay? Okay, so this is the initial filter context. If we look at our measure again, the very first thing we run into is the calculate function. And what the calculate function is going to do is it's going to create a frame within a frame. So calculate is going to remove any filters on dish. Remove dish filters. I can spell, I promise. I'm just not doing it because I don't want to. Okay, so calculate will create a frame within a frame. And so this new inner frame is going to have a new filter context. I'm just going to do, actually, I'll write it out. I'll be good. Filter context. Okay, so what is the filter context inside this frame? Well, we said to remove filters for sale dish. We've got this filter for lunch. Well, that's on sale shift, so that stays. So I'm going to do lunch. This is going to be on sale shift. And it's still a one row by one column temp table. And we're actually going to remove the filter on dish, right? Because we said in our code, when we create this new frame, I want you to remove filters, right? So this is the new filter formula. It'll run in a second. But the new filter definition is get any filter, remove any filter on dish. So I'm just going to draw it and then cross it out, right? And you know, if I was doing this in real life, I might not even draw it. I might just draw an X. But what the heck? I'll be good. So I'm going to do pasta. This is based on sale dish column this time. It is one row by one column, and it is gone because that's what we told calculate to do. So now in this new inner filter context, we've got a filter for lunch, but no filter for pasta, right? And so now what are we going to do? Well, we're going to go run. We're going to go run this guy here, which is the new filter formula, right? The formula we want to run inside of our inner frame. What is this going to do? Well, it's pretty simple. We're going to do a snapshot. So I'm going to do my best drawing of a camera. This may win some awards. All right, I'm just going to type in sale. That's that snapshot right there. And what does it produce? It produces a temp table that has all the visible rows of the columns of the sale table, specifically not one of the columns, but all of the columns. I'm going to draw a little star like we're in DOS mode, right? Now this temp table, because this is a very small data model, normally I would just guess its dimensions. I happen to know what they are, right? We're just looking at the lunch rows. Hey, Brian, should we just filter out pasta as well? No, we got rid of the filter on pasta. So we've got these 4 rows right here for pasta and burger, but just for lunch. And so this is 1, 2, 3, 4 rows. 4 rows by 1, 2, 3, 4, 5 columns. 5 columns, okay? So what do we do with the temp table that comes from this snapshot right here, the auto snapshot, which I usually underline? We're going to pass it to the count rows function. What does count rows do? Well, that one's nice and easy. So count rows. It takes this temp table, which is, oh, should have moved it away. Takes that temp table right there, right? These are the same thing. And says how many rows are in it? Well, I just said there's 4 rows. There's 1, 2, 3, 4. So count rows says there's 4 rows. And that is our final answer. And that is how you can do a DAX sketch from scratch using a whiteboard or a piece of paper. You can make these more verbose or less verbose. They're good for a lot of different things. Okay. Questions about that or anything else I've covered so far?
So Brian, I've got a question for you. That is, so let's say somebody's learning DAX and they're following your lead here.
Yep.
Do you, as you become more and more fluent in DAX, do you skip past the sketches?
Yeah. So unless something's really broken, the idea here is this, takes a lot of pen strokes, right? So this is good if something is broken or if you're teaching folks new concepts. In practice, the idea is you do this just enough time so that you could do it in your head without having to do all the pen markings, right? You're trying to develop that table vision that I was talking about before, where you basically do this exact same stuff, but it's just in your noggin, right? So usually it's mainly for teachers. You could use it to triage some particularly gnarly thing, or or to teach a concept. But again, if you're teaching a concept, it's still sort of a mentor student kind of a thing. So usually it's for teaching DAX, I think, is the biggest use of it. Does that answer the question?
Yeah, so teaching DAX or learning DAX. Yeah.
That's right, yeah.
Got it.
Yep. Have I created a Lucidchart template or something like that? I've been looking at that, and no, I haven't created one yet. I think that's something at some point when I get more time, I'll be able to maybe do something like that. At this point, I just haven't had the time. And also, I think, usually this works pretty well. Actually, in my experience, this works best when I'm with a student, right? And I'm trying to sketch something out, and they can actually watch me do it. Now, I guess if they could watch me do it in Lucidchart, that would work pretty well as well. But it does tend to work the very best when you're doing it like on a whiteboard proper, right? But that's a good idea, and maybe I'll get the ability to do that because I think it would be pretty useful. Thank you very much. All right, I'm going to turn this camera off and see if I can get the regular camera back on. Let's see, and turn the camera off. And my ego care about that as well. Okay, let's see. Did it live? Hey, there's me. Sketches. Okay, well, hey, we're doing pretty good on time. I think we're just about where we wanted to be. Any other last questions before we call it, we declare victory and head on back to our lives?
I don't see any more in chat. A few thanks. And Brian, thank you so much for agreeing to be our speaker tonight. And interesting topic, and I can see where this can really be a big help coming up the learning curve on DAX, or probably applicable to other types of languages or tasks we work our way through.
It really isn't that complicated of a language. Like it doesn't make it not hard like chess. The ideas are simple, but it's still difficult to master. But if I can make the simplicity of it, maybe the elegance of it show up for you, that makes me really happy. That makes me really, really happy. You're very welcome.